In this video, we will learn about the third and final method for solving systems of linear equations, which is called the elimination method. Elimination is an algebraic method that you would use to solve systems that are not easy to solve by substitution, the method we've been using recently. In the first system of equations that you can see on your screen, this would be a good candidate for substitution because it has one variable that has a coefficient of 1. So it would be easy to solve that equation for x and easy to use substitution. On the other hand, in the second system that we see right here, none of the variables have a coefficient of 1 in either equation. So that would mean that solving either equation for x or y would take more work, and so substitution wouldn't be that easy. Now, the answer in a situation like this is not pulling your hair out, not to get frustrated. It's just to use another method, and that method is elimination. So elimination works when in both equations one of the variables has the same coefficient with opposite signs. So we're looking for something like we see in this system. We have the y has a coefficient of 2 in both equations, but one is a plus and one is a minus. When you have this situation, you can solve the system using elimination. The first thing that you're going to do once you see this is you're going to add the two equations together vertically. And this is the most important step. So I'm saying make this into a big division problem and add the x's together. 3x plus 3x equals 6x. Positive 2y minus 2y, those are going to cancel out because they're opposites. So in that step, y was eliminated. That's where the name of this method comes from. And then on the right side, 7 plus 1 equals 8. Once you have done that, you should be left with a very simple equation with one variable in it that you can solve, usually just by dividing. So in this case, we have 6x equals 8, so I'm going to divide both sides by 6. And that gives me x equals 8 over 6, which I am going to reduce to 4 over 3, dividing the top and the bottom by 2. Now that we know the value of x, we need to find y. And we're going to do that by plugging x back into one of the original equations. Now it doesn't matter which one you pick, so I think I'm just going to pick the first one. So the first equation is 3x plus 2y equals 7. So I took my 4/3, and where I used to see x, I put the 4/3. So when we do 3 times 4/3, I can cross out my 3's, and I'll get just a 4 plus 2y equals 7. And if I subtract 4 on both sides, I'm going to get that 2y equals 3. And if I divide by 2, I'll have that y equals 3/2. So now I have the value of my second variable. At this point, we know x and y, so there's only one thing left to do. And that's something that we've done for every system we've solved so far, to write the solution as an ordered pair. So in this case, the ordered pair would be the x first and then the y. So we have 4/3, comma, 3/2, and we've solved the system with elimination. Now, sometimes elimination problems aren't so easy. Sometimes, if you look at them to begin with, they don't have the case where one of the variables has the same coefficient with opposite signs, and we see that in the example that you see on your screen. When this happens, you need to do an extra step to make it this way. Because here's an example of what you can do. You can notice that if we multiply this second equation all the way through by -3, we would get negative 12x plus 9y equals negative 18. And what I just did was I made it so that the y's now have a -9 and a +9 as their coefficient. So if I add the equations together vertically, the y's would cancel out again. One thing you'd want to notice here is that since I knew that there were negative signs on both, besides having to multiply the second equation by 3 to go from 3 to 9, I had to do -3 to turn this negative sign into a plus. Once we've done this, we can do elimination as normal. So the first thing I just did was to recopy the first equation so that I can see my whole new system in red. And the first thing that I need to do is add the equations together vertically. So when I do this, negative 12 plus 5 gives me negative 7x. My positive and negative 9y's are eliminated, and on the right side I get negative 21. This gives me an equation that's easy to solve just by dividing by negative 7, and I get that x equals positive 3. Now that x equals positive 3, I want to plug that back into one of my original equations. So I think I'm going to use this equation to plug back in. I could have used the other one, just my choice. So I'm going to do that right over here. I'm going to start with my 5, and then for my x value, I know that that's now 3. And then I need to say minus 9y equals negative 3. So that's 15 minus 9y equals negative 3. I'm going to subtract 15 on both sides, which gives me negative 9y equals negative 18. I'm going to divide both sides by negative 9, and I get for my answer y equals positive 2. Now, before I finish, I just have one last thing to do, and that is to clearly write what the solution is. And so the solution is going to be x comma y, so 3 comma 2. And so I know that if I graphed these two lines, they would intersect at this point. Now at this point, you're ready to start doing elimination on your own. But I just wanted to expose you to a couple more examples, at least how to start them. We won't go through the whole problem. So in example 3, we see these two systems, negative 8x minus 4y equals negative 8, and negative 5x minus 4y equals 10. Now this would be great if the y's had different signs. They already have the same coefficient, but they're both minuses. So I could easily fix this by taking this first equation and multiplying it by negative 1. If I had wanted to, I could have also done the second equation, but I picked the first. So that gives me positive 8x plus 4y equals positive 8. And when I add these together to do elimination, I will see that the y's cancel out, and that's exactly what we want. Now, if I take a look at number 4, I've got a 6x and a 12x, a 3y and a 4y. So the easiest thing I see is that if I multiply 6 by 2, I'm going to get 12. And since they're both positive, I'm going to multiply by negative 2. So if I multiply this first equation by negative 2, I'll get negative 12x minus 6y equals negative 36. And now, if I were to try to add these two equations together, I would see that the x's would be eliminated. We've seen a lot of y's getting eliminated. It's also possible for x's to get eliminated, and we'd be able to solve using elimination. In your notes, try solving this system using elimination. Refer to the steps on the right side of the screen. We'll talk about it in our next class.